In this training video, we continue with our discussion of the Mack method and the ELRF modeling framework. So first of all, let's open the database. Open database icon up here, Workbook 104A if you don't have it selected already. And by default this panel is selected, so let's just start typing in MA. And what typing in this panel actually does is takes us to the first triangle group that begins with whatever letters we type. So because we typed in MA, that took us to the first triangle group beginning with MA. So let's now select Mack. We might need to scroll down a bit to view it. And just double click on it to open it. So it's the same triangle group that we looked at in the previous session. So we mentioned also in the previous session that the default method in ELRF, which is the Mack method, gives us exactly the same ratios as the volume weighted average or standard chain ladder. We'll show that now, but make sure the ILC dataset is selected. In the ELRF, we only operate on cumulative datasets. Open ELRF. Go back to the triangle group. Right-click on the triangle group tab. You'll note that I right-click on the tabs a lot, and the reason is that it allows us to select between whatever windows are open, which is actually very handy when you're doing normal analysis, when you've got multiple triangle groups or multiple things open. So ILC is still selected. Let's open LRT. We now go to the downward arrow and tile vertically and select Minimize Triangles. And we can now see the two windows displayed side by side, the ELRF window and the LRT window. Just scroll to the right so I can see what ratios are estimated. I'm now going to select Ratio Selections in the LRT section and maximize the selections by double-clicking on the title. And what we see is that for the standard chain ladder ratios, they're exactly the same estimates as the ELRF parameters. So the Mack method, which is the default method, has given us exactly the same ratios. So 2.99936 is the first one, the 1.62352, 1.62352, and so on. So the Mack method is exactly the same as the standard chain ladder. All it is formulated in a regression format. Okay. Before we continue, what assumptions does the Mack method actually make about the data itself? So return to the PowerPoint slide. And the first assumption that we make, which is fairly obvious, is that the next y value, or the cumulative, lies on this hypothetical trend line. So given some value of x, our first assumption is that the cumulative for y lies on this line. The next assumption that we make actually comes from the variance equation. So in the variance, we say that delta is equal to 1. Remember, delta equals 1 gives us the Mack method, same as chain ladder ratios. What does that actually mean? Well, it means if we come back to this previous slide, and I'll just make sure I've got the red selected, it means that the variance that we expect to see, or the scatter around this line, is increasing as x increases. So what we expect to see in terms of scatter is something that looks like this, where these are symmetric lines. So as x increases, because our variance is proportional to x, the epsilon here is proportional to x, we expect to see this kind of structure around this trend line. So because we're making these assumptions as part of fitting the method, we actually need to test these assumptions to make sure that the data that we're looking at actually holds. So the assumptions actually hold given the data. So let's return now to ICRFS-Plus. We'll close the LRT. Incidentally, before I do that, note that the window title bars actually give you an indication of where you are. The first thing is the triangle group that you're looking at. Okay, it's Mack. ILC, we're looking at the ILC dataset. Then we're looking at the modeling framework we're using, or the module. We're looking at ELRF on this side. We're looking at LRT on this one. We've then got the output table that we're looking at, and LRT only has one output window, so it's all just an LRT. So let's close LRT now. Just click on this X button. And now we're going to focus on ELRF and the remaining two videos on these methods. Now, the first toolbar first button we're going to look at it on this toolbar detail is actually the YX button up here. It's the blue Y with an X. Let's open that now. And we're also going to open the data set as well. So come back, right click on the triangle group, select Mac, it's good practice navigating, and double click on the data set to open it. And again, we're going to go downward arrow, minimize triangles. Actually minimize triangle groups because we've got a data set open. Now, we'll also minimize the regression table so it's easier to see. And what we see in this display, we're looking at the first graph here, cumulative 1 versus cumulative 0. Well, what is this actually plotting? Well, it's the same as we saw in the PowerPoint slide. That is, we're looking at the previous cumulative, or X, the X-axis, and the next cumulative 1, is the Y-axis. So, for example, we can see at this point 5,000 is 5665 here, and the next cumulative Y is at 11,555, which corresponds to this point here. So this marked here corresponds to those highlighted cells in the table. Similarly, this point here at 557 corresponds to 4020. So this point here is simply the Y X at 1987, 0 and 1. The red line is the Mack method. So that's the best fitting line given that we're forcing the equation to go through the origin. So the link ratios always go through the origin. This green line, which we'll look at in more detail, particularly in the next video, is the Murphy method, where we add an intercept to this equation and say, well, we're going to fit these ratios, but we're not restricting the best fitting line to go through the origin. So in this case, it's going through around about 5,000-ish. And we can see straight away from this plot that the green line is going to give us a much better fit to these points than this red line. But we'll look at that in more detail later. What we're going to look at now is I'm actually going to quickly run through these buttons on the toolbar so that when we're referencing them in later videos, it's clear what we're doing. First button that we've got is the model templates button. If we open that up now, just left click on it, we're going to cancel out of it, it's okay. The model that's currently selected is ratios only and delta 1. This is the Mack, corresponds to the Mack method where we've only got ratios and delta is equal to 1. In ELRF we can extend these equations, as we'll see, and offer different values of delta, correspond to different weights. We've also got different combinations of intercept, trends, and slopes, with slopes being the ratios. Ratio and slope are synonymous. So this model template just allows us to quickly select some different combinations of trends and ratios and values of delta. Cancel that now. The next button in our toolbar is the Load Model button. That allows us, same as LRT, just to load previous selections that we've made or previous models. Same thing. And as you can see, I've previously saved a model that I've termed Mac. Cancel that. The next button in the toolbar corresponds to model parameters. So once you've actually fitted a model, you don't want to go back to the model templates necessarily, but you want to add some different combination of trends and ratios. We can just click in this table and it would say add a Y to say whether we're using an intercept, and if we click again it will remove it. Cancel that, and similarly with trends. We'll cancel that now. If we go to change delta, again we can change delta on the fly. We don't have to necessarily go back to our model templates. Cancel that. This TU is changed to ultimate ratio. So same as LRT, we can actually have a ratio to ultimate. We can do the same thing in ELRF, and we just actually set the values. And we can also specify a standard error to associate with that estimate. So because we're using a regression formulation, we can actually do that directly. Cancel that now. We've also got the variance to periods. We'll cover that in more detail a bit later, but it just corresponds to whether we're using these periods or not. We've also got the observation variance list, which just is a list of points we've excluded as outliers. By default, we're not excluding any points as outliers, so this table is actually empty. Close that now. Optimize, we'll cover that in the next video. This E to estimate here is, allows you to, if you've removed points as outliers, you need to re-estimate the equation. You just click on that. Regression table we've looked at is just the estimates of the parameters you're fitting. So because we're not fitting any intercept or trend in this case, we've only got the ratios and the corresponding probability values of those ratios, whether they're actually significant or not. We've got the option to save the model. That's this pink M with the downward arrow. Save model corresponds to this load model button over here. This allows us to save our current selection into the database. Next to that, we've got the residuals display, which is actually what we're going to be looking at next. Is green diamonds here. We've then got the 3D version of that residual display if we wanted to look at it in three-dimensional form. We've got this hourglass with 3 diamonds. It's one of our diagnostic displays. We can look at that as well. YX plots, which we've looked at over here. I'll just drag that window out of the way. We've got the logbook, which just, if I click on that, just gives us some summary statistics about our model. It's forecast information. We've actually computed a forecast. Same as LRT, this green triangle with the downward yellow arrow corresponds to the forecast button. Once we actually complete a forecast, then we can display the forecast tables and forecast summaries, and we'll look at that in the next video. But for now, we're going to return to the residuals display, so close the logbook. Click on the green diamonds related residual plots, and we're actually going to maximize that display. Okay, by clicking on the maximize button. So we're going to look at each of those buttons in more detail in subsequent studies, but for now we're focusing on the main ones that we're actually going to be using. So the first one, as I said, we're looking at the residuals. And it's helpful to think of the residuals as the difference between trends in the data and trends in the method. If the model is good, then one criteria is that the residuals do not show any pattern or any structure remaining in the display. And if that's the case, then the trends in the method are the same as the trends in the data. And that's actually what we want, because we want our method to describe the data. Now, the first thing that we note just looking at this display as by eye diagnostic is we've got residuals that are trending downwards. All right, we'll cover that, exactly what causes that shortly. But first of all, let's relate these residuals back to the actual data itself, and in particular the YX plots, because we've already related the YX back to the data. So first of all, we're going to click on these buttons at the top here. Well, as soon as you do that, left click, you'll see this black line. Now, if we do that for the remaining ones, what is that actually doing? Well, the black line, and you see it toggles if you click it more than once. The black line just excludes those points from the regression equation. So we haven't actually estimated anything yet. We're just marking what we're going to change. And now we're going to click on this lightning bolt with E to actually estimate that model. Okay, so now we're just fitting the regression equation between 0 and 1 and just getting the residuals corresponding to that and weighting it accordingly. So if we look at the YX plot as well, we're going to tile vertically minimizing regression tables this time. And we can now see the residuals in this panel, and the window on the right, and see the YX plot on the left. Now what we see is that for this residual here, which is 82, development 1, calendar year 1983, you notice the tooltip that comes up when I put my mouse over that point will correspond to this residual, I believe, here. And if we just let's check that by opening the data as well. Didn't think I'd need that, but just right click on the triangle group, double click to open the data, minimize this triangle group window, and we'll tile vertically again, just so that we can relate it back. So we're saying accident year 1982, this point, it's actually this point and it corresponds to that one. So it's actually this point here. It's saying the difference between this point and the regression line, given that we're expecting the variance assumption, so the variance will increase. Remember, we're looking at the weighted residuals here, so it's weighted by the variance. We're saying the actual largest residual, once we adjust for the variance, is actually the difference between this point and our fitted ratio. So remember, in our variance assumption, we're expecting the variation to be very, very small, because we've got x small at 100, we expect the variance to be small, so as a result of that, once we scale by the variance, we get a very large residual here. Okay. If we come back to ELRF now, right-click on the ELRF tab, ELRF, click on the accident year title button. Let's look at the next period. So click on development, untoggle 2, the second button here, and toggle the first one, E to estimate. We're now looking at the second cumulative versus the first incremental. So we're actually looking at these two columns here. Well, what do we see? Well, we actually see a different residual as being a really large residual this time. It's in, if I put my mouse over it, it's an accident year 1987 and development period 2. So 1987 development period 2, it's this point here. You see our X is actually 4,000 and our Y is somewhere up 10,000. So what it's saying is the difference between this point and the fitted Mack method, the red line, is once you adjust by the variance, corresponds to this large value here. Similarly, you get this negative value in probably this one here is accident year 1984 and development period according to that one. So it's 11,000, 15,000 here. So it is that point. So this is the largest negative value once you adjust for the variance. Alright, so that shows us how to relate the residuals that we're fitting to the link ratio method that we're plotting and also the data itself. In order to estimate all the regression equations between the periods simultaneously, in other words, to untoggle all these black bars, just click on the upper left box here and then click E to estimate. And that'll estimate all the regression equations again simultaneously. Maximize that. We'll now close this dataset view in tile. Okay. Now, let's look further at the residual. So we've observed this downward trend. What is actually causing this? Well, if we look at this YX plot here, we're seeing that our regression line is forced to go through the origin. So as a result, we're actually underfitting these values. So all the residuals in this section, the trends in the data minus the trends in the method, that's what a residual represents. All these values are positive. And because we're overfitting, the tendency is these trends go downwards, so we actually end up having higher values than expected on average for these points here. Alright. Now, if we actually had the fitted an intercept now, let's do that. We'll right click on the ELRF tab at the top here, click on New Module. Okay, it's open a second instance. You can see the number 2 here. Let's fit the Murphy method. And the Murphy method just adds the intercept, so we're looking at this green line now. So go to Model Templates and click on both. Now you see we've got intercept yes and ratio yes. Click OK. We now look at the residuals, the green diamonds up here, and what we'll do is we'll look at the two displays side by side. So click on the downward arrow, minimize other types. We've got the Murphy method on the left, we've got the Mack method on the right. And you can see that this downward trend that we saw in the residuals versus fitted has now been removed when we fit the intercept and use the Murphy method. Okay, so the equations that we're fitting now on this left side, if we go back to the PowerPoint display, just go down a little bit, and next slide, we're now adding this intercept into our regression equation. So previously, we're using just the ratio plus an error term. Now we're using an intercept plus a ratio given the intercept and an error term. So the ratios B here are very different estimates because we're now using an intercept term as well. And we're using the same assumption of delta here, delta equal to 1. Right, in the subsequent video, we're going to look further at the Murphy and other related methods in the ELRF. But this concludes this training video. Thank you.